Okay, can you see my screen now, guys? Can you see my?
Yes, sir.
Okay, great.
Yes.
Okay, so I think someone has shared the data set. So that's the data set advertising. If you check the data set, let's look at the data sets together. So it's actually advertising expenses and the number of sales recorded for those records. So if you look at it now, you can see we have record for TV, record for radio, newspaper, and sales. These three columns are independent variables, right? The sales is the dependent variables. So what we are doing basically for this lab is to find out the relationship between TV and sales. For this particular lab, we are using just one of the independent variable, which is the TV. So we want to develop a linear model for TV and the sales. So that's what we are doing basically. So I'm going to show you the lab manual. So basically for the Python class, we are implementing linear regression and we want to be plotting the regression line. So this is the link to download the data set. Someone has shared the data set with the class. You can download it directly from the team. So like I said, the objective is to analyze the relationship between the sales and the TV. But for this class, we are using just the sales and the TV. You can do the others at your own convenience. So this is where we are starting. So I'm going to give you a kind of overview of what each of the lines of code are doing. Then I'm going to show you the demonstration on Colab. So let's start. So basically, these sections here is to import the necessary packages. You can see we import drive here, then we import pandas here, we import numpy as np here, we import matplotlib, and then we import linear regression. What does this import, what does it do? For drive, it is to connect your Colab to your Google Drive. So by using these two lines of code, you are basically mounting your your Google Drive on your Colab, meaning that you are giving your Google Drive, you are giving your Google Colab the authorization to get data from your Google Drive. Because the data you want to use, you have to upload it into Google Drive. So while I'm talking, I want you guys to upload the data, that advertising.csv, to your Google Drive. So we are going to use these two lines of code to connect our Google Colab to our Google Drive. So you want to start uploading now. Then the pandas is, I think I told you about this one last week. The pandas is a package for, you can see, for reading a lot of CSV and other type of files in Python. It's very important. In fact, you cannot do data analysis or machine learning modeling without pandas. You can think of pandas as a, Excel. Look at it as Excel. It is pandas that you are going to use to view your data in form of tables. We are going to look at it later. So here, like you see, we are using pandas module now, and then we use the read_CSV method of the pandas package to read our advertising data set. You can see, basically this one is just reading the advertising data set, and then it is now storing the data set as DF, right? It's storing it as data frame, DF. So now here we import linear model, linear model, because we are doing linear regression. So that linear regression model is inside a scikit-learn. This is scikit-learn, sklearn. And then inside sklearn, we have the linear model package. But then it is inside that, because you have so many models inside the linear model package. So that's why we use another import here from sklearn, sklearn.linear model, import linear regression. So basically, this one is just to import the required machine learning model we want to use. So if we want to import, assuming that we want to use support vector machine, instead of importing linear regression, we are going to import support vector machine. But mind you, SVM is not inside linear model. Basically, maybe perhaps we are going to see that later in one of the next labs. Okay, NumPy here, we import NumPy also, and I told you NumPy is for arrays and then matrices. So then we import matplotlib also for plotting our variables. So basically, these are to import all the necessary packages. Then, okay.
Sir,
Yeah.
can you explain about the pandas again?
Okay, pandas. Don't worry. Just take it as I explained to you for now. We are going to see the demonstration. So I'm going to take note of your question so that when I'm doing the demonstration, I'll be able to, let me just write it down. Or perhaps if I forget when I do the demo, you should remind me. So pandas. So don't worry, you get to understand by the time we start the demonstration. I just want you guys to have a kind of overview of the whole thing before I start the demonstration, right?
All right. Okay.
Okay. So then, for the plot now, what we want to do, the first thing in any machine learning, or one of the important tasks in any machine learning pipeline, is to plot your variables. By plotting, you can get a visualization of how the variables relate. So here, what we are doing is, because since we want to have a model between sales and the TV, so we are plotting the two variables, right? And then we are using scatter here as the kind of plot. So you guys don't worry, we are going to see what each of these ones are doing. Then here, what we are doing basically is, we say that for our data set, we have 4 columns, right? But then since we are doing simple linear regression, it implies that we are using one independent variable instead of all the 3 independent variables. So we have to specify which of the independent variable we want to use. So this is what this line of code is doing. By saying x equals to df in bracket tv, we're actually specifying the independent variable we want to use. So I'm going to explain this one better. Then also here, y df in bracket sales, we are specifying the dependent variable, which is the y variable, and it is sales, right? So here we are creating the linear regression model, right? Remember, we import the model here. So here we are calling the model. This is basically just like initiating the model. We are initiating the model. So the next line here is very important in any machine learning. This is fitting. We are fitting our model with our data. So you can remember that our x is our independent variable, our y is our dependent variable. So now when we now fit, we are going to call the independent and the dependent variables as the input to our fit method. This is a fit method. So that means that fitting is, machine learning is all about making computer to learn from your data, in order to perform a task from that experience. So to learn from the data, we use the fit method. Remember, we call the fit method on the machine learning model. Okay. So then after the model has learned from the data, after learning from the data, what is the outcome of the learning? The outcome of the learning, especially for linear regression, is to fit a kind of, what do you call it, best fit line. The best fit line into our variables. That best fit line is going to be used for the predictions. That means that by so learning from the data, the machine learning model can now say that, okay, from my experience, I think this is the best fit line that can be used for further prediction of the data set. And that best fit line, especially for simple linear regression, has some parameters, which are the intercept. You know, when you want to draw a line, you have the intercept and you have the slope. So basically, after that, what we are doing here is we are now predicting. We call the predict method on the linear model. So what this one is doing basically is that we want to find out how does our model, what is going to be the prediction for the sales that our model is going to give us. Then we can now compare that prediction with the actual value. Remember, the actual value of sales has been stored as the y variable, whereas the prediction is now stored as y predict. So now these two lines of code, now these three, basically you can call it two, is plotting the actual sales and the predict. Here is comparing. So we are using predict as the line, and then we are using the actual as the scatter. So here basically what we are doing is that we are determining the score, the assessment. This is to assess the model. So we, assessment of the model, we have different assessment metrics. You can use coefficient of determination basically. So when you use the score method, it is going to give you a value. That value is by default coefficient of determination. But then you can also find other metrics like mean absolute error by writing the codes for it. Okay, so I would like to stop here, and start the demonstration of what I have said so far. If you have any question, you can ask me along now. Okay, so what I have explained basically is what I want to demonstrate here. So just so that you know, what I have in my lab, in my notebook here, is all these lines of code here. But what I try to do is that I try to write it independently, like one code after the other, so that you're going to see what each lines of code is doing. So now, remember, you must have imported your data set to your Google Drive, have you?
Yes.
Okay. Now, the first thing, since we want to get our data, excuse me. Okay, so the first thing is to connect our Google Drive to our Google Colab. So how do you do that? Guys, listen. I want you guys to observe something. If you look at the left-hand side of your Google Colab, you are going to see an icon called Files. If you click on that icon, for now, you see that there is no connection. This is to browse your files. There is no connection at the moment, right? Can you see that?
Yes.
Yes.
Exactly. There is no connection at the moment. Now, except for if you are careful, if you are patient, you're going to see a folder called sample data. That sample data is just the default folder that is there. If you click on that sample data, it has some data set already, and I told you it's a default folder that Google Colab puts in the environment. So if you want to do some quick machine learning, you can use these ones. This is a California housing data set, and it's a very popular data set for machine learning modeling. This is MNIST data set. This is a very popular data set for deep learning modeling. This one is for you want to identify or detect handwritten digits. So it's very, very commonly used for deep learning. Anyways, but then we are not using any of these data sets. We want to connect our Google Drive. So if you look at this, okay, let me delete these ones first. I want you to see what happened. Now, if you check this folder at the top, you see mount drive. You see, you can mount your drive here. Here, you can actually connect from your what is it called, local computer. But then we want to do this. So if you click on this, look at this, mounting Google Drive. Now, it will ask me, permit this notebook to access your Google Drive. If I click yes. Now, basically, I want to permit it to access my Google Drive. So I'll just click on my this thing, my browser is started again. Oh my. So basically, it is mounting my Google Drive. Let's look at that. Okay, now you have, if you observe, before I mount my Google Drive, I don't have a folder called Drive before. If you observe, you will see that there is no folder called Drive initially before mounting the drive. But after mounting the drive, it has a folder now called Drive. Do you understand? Alternatively, what you can do is to use these two lines of code from google.colab import drive, then these two, you can use these two lines of code also. It is going to do the same thing. Do you understand? So this is how to mount your drive. Now I want to check my drive now. Now inside my Google Drive, these are the folders. I mean, these are the files that I have. I have this ADB challenge, okay. But importantly, this is what we want to use, advertising.csv. That's the important file that we want to use. I have it in my Google Drive already. So how do we start using that drive? I mean, that file. We have to import pandas package. Let me click on that. So I've imported that pandas package. Now I want you to take note of something. So I said pandas. If you want to check the method that we have, pandas dot. Now pandas is used for reading your files. If my file is in CSV, I'm going to use read_CSV method. If my file is in Excel, I'm going to use read_Excel. And you can also read from web pages. If you have, let's say you have your data in Wikipedia and it's a table, you have some table of data in Wikipedia, you can use read_Excel. So basically, pandas is used for getting your data and for managing your data. It's a very commonly used data set, package for data management. Do you understand? Now let's look at one of the use of pandas. For this use, we want to read our CSV file. So we call on pandas and we use read_CSV method. And then how do I, let me just read_CSV. Now I want to put my what's it called, the link or the root for that file. So to do that, I'll just click on this and I'll copy the path. Copy path. I didn't mean I want to read any of these things. I'll copy the path of the particular file that I want to read. But for this, I want to copy the path of the advertising and put it here. So I'll put it in quotes. Okay. So if I read that, basically, you see what happened now. Do you understand what pandas is doing now? Like I told you, pandas is just like Excel, and you can see that we have our this thing like this. So when we use pandas and then we use read_CSV, we are able to see what our data set looks like in form of tables. We call this data frame actually. So it's called data frame. So do you understand what pandas is doing now?
Yes.
Okay. Okay, now, so we have done that. So, but then basically, we want to store this data set, this data frame, as a variable called df. So that's what I'm doing here. So basically, this one is just storing it. Remember, this one is not storing as any variable. So this one is storing as df. Now, then the next set is to import the other packages that I told you about. So I'll just run that here. sklearn, numpy, matplotlib, and linear regression. So that one also has done that. So now I told you the next thing is we want to plot the data. So when we want to plot the data, we use df.plot. That means we want to plot what we are telling our this compiler is that we want to plot this data set, right? But then we have to specify what is going to be the x column and what is going to be the y column. That's why I put x to be TV here and I put y to be sales here. And this kind basically is just saying what is the type of plot. You can have many type of plot, you can have histogram and all of that. To find out the kind of plot that is possible, if you write df.plot, and then you're going to have that suggestion. You can check, you have the line plot, you have the histogram, the box plot, and you have the scatter that we use. Okay, guys, any question on that? Do you have any question on that?
Sir, actually, I want to ask about the previous thing you did, which is the importing the data from the drive. Does the second line of the coding has the same path as the fourth line?
Which one? Which one?
This
one?
This one, the path for this line and import drive.man. Is it the same? Has the same path?
Import drive dot. I did not get that.
Actually, I copy all from the lab manual. And
okay. You mean this from the lab manual?
Yes. Is it the second line?
This second line?
Yes. In the bracket has the same path as the fourth line.
This is the first line, you know.
The fourth.
The fourth. You mean the fourth?
Yes.
Okay, so like I told you, you see these first two lines is basically to mount your drive to your collab. This is the path. This is where you are, linking the path. This one is just to mount. You see that this one stops from drive, content / my drive. You see, and this is your drive. You can see this is actually mounting this particular folder, drive. But this second one is going inside my drive folder, which is inside drive, and then getting the advertising file. So basically, this is the path. This is the path. This is just to get to the root directory. This is to get the main file. You can see this one is like, more specific than this. Do you understand?
Yes, right.
Okay, so now what we want to do now is that we want to get our x column and our y column. Now, if I want to get my x column, my x variable, what I can do is I'm going to call a variable x equals my data frame. Remember, my data frame is that table into brackets. What is going to be my my column that I'm going to specify? What is going to be the name of the column? Is it newspaper? Is it radio? Or is it TV? I'm asking you. Remember the aim of this model is to do a linear regression between this TV advertising and the sales. So now, when I want to create my x variable, the x is the independent. Which of these four columns is going to be the x variable?
TV.
Yeah, it's going to be TV. So that's what we are doing. So we are getting the TV column as the X variable. So if I do that, let me, I want to show you the X now. So you see what happened now. It actually extracted only the X column out. And you can see we have 200 length because our data frame is 200 by 4 columns. So this one only take the TV column out of the data frame. Now that's what we are doing here basically. We are taking the TV columns out and we are taking the values. What is this dot values? What is it doing? Basically what it is doing is that you remember that if you look at this, you see that we have the index and we have the values. We call this one index, that column number. But then we don't need the index. We only want the values. So if you use x dot values, it's going to give you the values in arrays now. So you have the values in arrays, and then what you want to do next is what this reshape is doing. This reshape basically is, if you look at these values, you can see that it is along the rows. It's actually along a single line of something, but we want it to be a column matrix, not a row matrix. So we can use reshape now. Dot reshape, then put -1 because it's transforming, just like what's it called, matrix Z transformation or something. There's a particular something you call it in the matrix. So you can see what happened. So this one has made it a kind of column matrix. Initially it is 1 by 200. Now it is 200 by 1. You understand? So this is what, so basically what this line of code is doing is first to get the TV column, then get the values out, and then reshape it into a column matrix. So that's why I try to break it down for you guys here. So I'm going to delete this because it's just for you to understand. So this is what this one is doing. So we have gotten our X variable, store it as X. I mean our TV data, store it as X. And the same thing, we want to get our sales data and store it as Y. So we have our X and we have our Y now. Now what we want to do, like I told you, is first to call the linear regression model to initiate that linear regression. So we call the linear regression and then we store it as reg. You can use any name. You can use any variable name, right? But then to go with the names in the lab manual, so I'll just use this. So I have my linear regression model already. Then the next thing, like I told you, is to fit our data into our model, right? So to do that, you call the fit method. Like I told you, let me just try to tell you what this one is doing. Reg.fit. If you call that, you can see the suggestion is telling you that you have to input your X and input your Y. There is another parameter here that you can specify, but it's actually not, it's optional. So here, for our X, in our case, is going to be what? Our X is what? Our X for this
TV.
Yeah, it's TV. But mind you, we have stored that required data of TV as X variable. So that's why we put X here, right? So I mean that we store this one as sales, I mean TV here, we are going to put TV, but then just know that we have X and we have Y, and X is TV, Y is sales. So that's why we put X and Y here. So I'm going to delete this so I can now run this now. Now, when I do that, I'm going to have nothing but an output like this. This is indicating that I have successfully fitted my model to my data set. Now, my model is ready for further use. And the further use is for prediction of maybe, okay, if I want to find out what's going to be my sales for this particular expenses of TV advertisements. So I can do that. Okay. But then before we do that, I want us to check something. You know, I told you about linear regression model, that basically what linear regression model is doing is to fit a linear, I mean, is the best fit line, to get the best fit line for your data set. So, and to do that, we actually require some parameters like the intercept and the slopes, right? So you are going to see more of that when Mr. Naim is taking you the beta naught and the beta 1. So now, for our linear regression model that we have fitted, we want to find out what is the intercept and what is the coefficient. Remember that we have just one independent variable, which is the TV. So by so doing, we are going to have two parameters. The first one is the intercept, and the second one is the coefficient for that TV. So if I run if I call my coefficient method on the model, I'm going to have my coefficient. This is my coefficient. This is my beta 1. You can call this one beta 1, or you can call it M or something. And this is my intercept. If I run this is my intercept. So basically, you can say that your linear regression equation is going to be y equals to 6.97428, which is the intercept. Remember, your linear regression equation is just like the slope of a line, y equals to mx plus c, right? And from our fitting, our c is 6.97428, and our slope is 0.055464. So this is our linear regression equation. Okay, now, so we want to get like y predict using our model. Basically, what we are doing here is we want to use our model to predict for sales using the TV data. So that's why I call here, let me just write here, y predict here equals my model, then I call the predict method, meaning that I want to use the model to predict now, and then predict based on the TV advertising. So what I'm saying is that what is going to be the Y sales that you are going to predict based on the TV advertising. So if I run that, it's going to give me some Y predict. So I'm just going to run this one for you. So now we have this. That means that for each of the for each of the TV sales, we have the Y predict. So this is the Y predict. So what I want to do now is I want to compare my Y predict given by my model with my Y sales. With the actual sales that we recorded. Do you understand? So to do that, I'm just going to remember we have the data frame that has 4 columns. So I'm going to add another column to my data frame. I'm calling my data frame. Then I'm specifying another column. I want the column to be sales predicted. Then I want it to be these predict values. So I will just say let it be Y predict. So I will say let it be Y predict. So if I run this, now what this line of code is doing again is that it is creating a new column for my DF, for my data frame, and then it makes the value to be equal to the predicted values. So let's look at what that looks like. If I call my DF now, you can now see that now I have 5 columns. I have my actual sales and I have my predicted sales. So if you compare these, you see that our prediction in some records, for some records actually perform well, and for some it really does not do well like that. Like if you look at this is 17.9, the actual sales, when the TV is 180.8, the sales is 17.9. That's the actual sales. But when we use our predicted model, our model to predict the sales, it gives us 17.0. This is almost close, right? Now, we can actually do better. We can do better, but then one thing I want to point your attention to is that remember that we only use one independent model, the TV, to fit our machine learning model. We only use one independent variable, TV, in fitting our machine learning model. So we do not use all the possible independent variables, but then our models still perform well. So we're going to look at how we can use, maybe in the next class, how we can use multiple linear regression, whereby we now be considering all the other variables as well. Okay, now we have done that. Then the next thing we want to do is that we want to look at how this line, our linear regression model, how does it fit into our data set. So that's why we are using this basically. I'll just run this one. Now, this is, like I explained initially, we are using scatter diagrams here to plot the actual values, x, y, as a scatter plot. So you can see these are the actual values. It's just like you are doing your normal plotting of graphs. So when x is this, y is this. When x is this, y is this. Now, this is what this is giving us, the scatter values. Now, the next line here, you can see we have the color to be red. What this one is now using the red line to plot our predicted sales. So by so doing, we can see that this is how our linear model fits into our data set, right? And then if you look at it, basically, we have from our initial something, our intercept is 6.9, almost 7, and our slope is 0.05546, right? So if you look at that, you see that it almost agrees here. If you extend this line to the y-axis, you see that it's going to touch this thing almost around that 7 line. Around that 7 values. So this is our linear regression model line. Okay, so the next thing we want to do here is to find the assessment. We want to do the assessment of our linear regression model. So to do that, we are just going to call the score method, right? We are going to call the score method on our model. So when we call the score method on our model, we pass our variables, the x and y. So let's see what that gives us. So this is our score, this is our performance. So we get that our linear model gives our square of 0.8121. Do you think this performance, this model performs well or bad? Does it perform good or poor? Compare. Look at this score, 0.81. Is it acceptable or not? Remember, the score is coefficient of determination. What do you know about coefficient of determination? And then, do you think this score is okay for our linear regression model? Okay, let me give you an insight. Coefficient of determination can be between 0 and 1. It can range between 0 and 1. Now, for this one, we have 0.81. Someone should talk. Do you think this model performs fair, performs good, or performs bad? Why are you guys not talking?
The model is good.
Yeah, the model performs good because this is almost close to 1. So if you're having a performance score of 0.5, then that is really average. Anything less than that is so poor. Okay. So this is so what we want to do next in the next 5 minutes is that so we have actually done all this. We have fitted, we have predicted, then we have plot, then we have determined the score of our model. So what we want to do next, number 4 here, is we want to predict the sales for twice the mean value of our TV, right? So let me give you a scenario of where this one can be applied. Is that imagine that as the owner of the company, you want to find out, okay, maybe next year, if I double the expenses for the TV advertising, what is going to be the possible sales that we are going to record? You understand? So you want to find out, if I double like the mean of my TV expenses for next year advertising, what is going to be the possible sales that we are going to get? No. So a way to go about it is that you can use ordinarily this linear regression line. Since you have gotten your linear regression line, you can just use, remember we have, where is that line? We have this y equals to this, and this. So what we can do is just to plug in the value of our 2 mean of the sales. So that means we are going to find the mean of the sales, multiply by 2, and putting in as the x here. Then we are going to get the value for the y. So that's very simple to do. So that's what I try to do here. So what I did was I obtained the intercept again, and I print it here. So beta is now my intercept. This is my coefficient. And then what I did here was to find the mean of the sales. Remember, I used numpy dot mean of x, and you know that x is the sales. So when I run that, I'm going to get my MTV, which is the mean of the TV, to be 147 point this. You can confirm that from your Excel as well. If you highlight this TV column, you are going to see that the average value is 147.04 something. So this is the mean of your TV, and we have the same value using numpy. So when you use numpy.mean and you put your x, which is the TV, you have that. So what I did here basically is to use, I have my beta now to be the intercept, and I have my alpha to be the slope. So I now use y equals to m, which is the slope, mx. Now x in this case is double of the mean TV expenses, right? It's twice of the TV expenses. That's why I put 2 times MTV here. So basically what I'm having here is just like y is equals to mx plus c. So my c here is beta, my m is the alpha, and my x is now the the double of the mean TV. So I run that. Now if I call my y, so I can see that when I double double the mean of the TV, I'm going to get the sales to be 23 point something. Now, what happens if I triple it? Let's see. Let me call this one Y3. Then Y3 now. We expect that it should increase because Yeah, that's it. So when I triple that, it's going to give me this value. Okay, but then it's not really professional to be typing for each of the x variables. So instead of doing that, I can just put all of these things as a function. So that's what I did here. I defined a function called pred or predict. Then what the function is doing basically is it is going to take in the xi parameter, and the xi parameter is like, do you want to find the sales for the mean, or for the double of the mean, or for the triple of the mean, or for any envisage or plan increase in the mean. So now then I return something. What I return basically, if you compare this and this, you see that they are the same. So I just return, you can say return, you can make beta to be here. Beta plus this. So that's what I'm doing here. So I'm basically bringing this one back here. So now I can now call my pred now using that function. I can use the function to find out what is going to be the triple of the main TV. So it gives me the same function. So basically, this is how you use linear regression model, and I try as much as possible to explain to you guys what each of the lines of code are doing. So I know you have questions, and I know you have some areas that is not clear to you. In the next, I've actually elapsed my 1 hour, but in the next 5 minutes, I want you guys to ask me any questions, and I'll try as much as possible to respond. Okay, question from you guys.
Hello, sir.
Yeah, I'm with you.
Can I ask that just now when you talk about when you are defining a function for the prediction?
Okay. Okay.
Okay. After the bracket, right? What does the arrows mean?
Okay, this arrow basically is to ensure that your basically this is a way of enforcing the data types. It's like you want to enforce, you see that we are enforcing that the data types should be float. That means that the value we are going to return from this prediction is going to be a float. You can actually ignore it. You can just define, but it's a kind of advanced specification. You can just use define, let me say x, right? And then just return, basically. It is still going to work, right? Let me call this one predict 1. Now, if I run that, it's still going to work. Then I can now call, I just want to show you that it's just an advanced specification that you may actually ignore. Predict 3 x1 is not defined. Oh, sorry, I used x here, not x1. So you see, it still works. So it's still the same thing, but then this one is basically, it's not necessary actually, but then there are some areas that you want to specifically constrain the data types of your output to be float. I hope you understand what float is. Float is like decimal point. So that's when it is needed. You can take it out. So it's just to constrain the data type that the return from this function must be a float. Do you understand?
Yes, sir. Thank you.
Okay, good. Any other question in the next 3 minutes? I'll try to explain if I know it. No question from you guys again? Okay then, Mr. Naim.
Yes.
Okay. Before that, then any suggestion then? If you don't have question, do you have any suggestion? on how to make it something. Any suggestions?
Sir.
Okay.
Actually, right. I want to ask that because when we are doing this linear regression using Python, we can only check the coefficient of the determination, right? Is it possible to also check the p-value and the t-test?
Using Python, actually, it is you know, I'm not sure about that. I'm really not sure about that. But okay, let's do it together. In the next 2 minutes, checking p-values in Python. So I think you can do that actually. You can do that. I'm going to copy this link for you, and you can now lay your hands on it and then see how you can come up with that. So it's possible. You can do that, but you can explore. It's possible. But I actually have not been, one of the things that I try to run away from is that p-value of a thing. So you can check, you can explore. It's actually possible.
All right, thank you, sir.
Yeah, you're right. Okay, so Mr. Naim.
Yes.
You have the floor, sir.
Okay. Thank you, Mr. Nahim.
You're welcome.
Okay. Actually, for that question, the one that what finding p-value using Python, it is possible, but I think for your syllabus for Python coding part, it's just enough for you to at least know how to find the regression equation and also to estimate the value. That's all. No need to find the p-value and so on by using Python. I think for the syllabus of your coding part, it's enough if you just refer your lab practice. That's all. So for the p-value and the standard error or something other than that, you can find using your Excel. Okay. So we proceed with tutorial. Okay, can you see my slide?
Yes, sir.
Okay, good. Okay, have you tried this question set? Guys, have you tried it?
Yes.
Okay, good. So I just want to just simply go through the first exercise, the first question. Is there any problem with this? I think you can get all the answer, the information from the lecture note. For the first question, general simple linear equation is just y is equal to beta naught plus beta 1 x. Something like that. What does B naught tell you? Is there
Sir,
any yes?
So actually, right, for the general simple linear equation, right,
Okay.
when do we need to add the arrow, symbol at the back?
Arrow symbol. Okay. Normally, if they just ask you to find the linear equation simple, something like that, no need to put the error. Okay, just simply put this equation, because when I see your syllabus, the lecture note didn't put any information about how to find the error and so on. They just introduce to you is actually there is an error, because in real situation the data is not linearly like this. It's not like this. It can be scattered, especially in data analytics. You will involve big data. So if you develop one regression model here, this is your regression equation. Your regression equation, this straight line, is actually this equation. But when you consider error, you want to compare with the real data, then you can plus error. But for your syllabus, you just consider this equation without the error. Is it clear? because this is only the
Yes.
straight line. The straight line we don't consider the error. For the straight line, if we want to compare with the real data, then we can put the error. Then you need to calculate the error lah. But in your syllabus, they just introduce it but not use it. Is it okay? Clear?
Yes, sir.
Okay, good. Next, any question? I think everything here can be found in lecture notes. Any question? You can just ask me for the exercise 1 questions that you don't know. This one and also this one. I think for the first slide here, it's very simple. B naught is the intercept. B1 is the slope, or sometimes we call it gradient. Okay, what if the slope B1 is equal to 0, meaning that no relationship? ANOVA tell you. This one you can find it in your lecture note. SST equal to SSR plus SSE. So is there any problem? Can I just go to the next slide?
Yes.
Okay. Good.
Sir, how about
Yes,
the question number 6?
Number 6, wait. 1, 2, 3,
The
4, 5,
test
6.
involved in ANOVA.
Okay, good. Remember, in ANOVA, take note please, in ANOVA, only F-test. Remember, F-test is only for ANOVA. Okay, any question?
Sir,
Yes.
is it the question refers to macam what value test tu dalam ANOVA table? Is it?
Yes, yep. Any question?
Bukan ada like t-test,
Okay, t-test. Okay, if this one it's already stated here specifically for ANOVA. ANOVA is only involve F-test. Okay, later I will explain this part.
Alright.
Okay, any question? No, can I proceed?
Yes, sir.
Okay, thank you. Okay, for this part, for this slide, how do you evaluate your linear regression model based on the software output? You can use R-squared, you can use your standard error of estimate, you can do hypothesis testing. Okay. Your linear regression model. This is very important for you to understand. You can use ANOVA, hypothesis testing, F-test. Okay, so next, standard error of estimate. Okay. This one, in the software output, standard error of estimate is the square root of MSE. Remember this question? I want to explain more about this question. Remember square root of MSE. So standard error is actually square root of MSE. This is actually square root of SSE divided by degree of freedom for error. Later I will explain this. So for the next question, I think this one you can get from the lecture note. Is there any question that you want to ask? For this part, it's just understanding the concept. So I don't want to, take more time on this. Is there any question for this slide?
How about the last question, sir?
The last question. For the hypothesis testing, which statistical test is more flexible? This one you can get the answer from the lecture note if you read the lecture note lah. So more flexible is t-test. Okay, remember, as I said just now, ANOVA only use F-test. But for hypothesis testing, you can do F-test and also t-test. I mean, these two tests actually can do hypothesis testing, but for F-test specifically for ANOVA only. Okay, So to do ANOVA by using F-test, you need to do hypothesis testing, but only involve F-test. For this question, they ask for the hypothesis testing. So for the hypothesis testing, we have two tests, F-test and T-test. Okay, more flexible is actually T-test because we can try for one-sided and two-sided. For this one, we can try only for two-sided. That's why I said F-test only for ANOVA. Why? I will explain later. Okay, clear. So for the last question, the answer is T-test lah, because we can consider two cases here, one-sided and two-sided. Okay, any question?
No.
No. Okay, good. I will proceed to the next slide. Okay. This is actually manual calculation. As Dr. Hanita said before this, supposedly you will be taking a final examination, but based on the current situation, I think UTP will continue with the extended assignment, I think. So maybe for this exercise, you can just use your Excel, or if you want me to explain about this, yes, I will just go through. So to find the okay, for the purpose of verification, you need to estimate the linear regression equation between the fungus concentration and also lipid productivity. Okay, if you are given with this question, first you need to identify which one is the independent and which one is the dependent variable. It is very important. If you place the variable and you just make it as the input of your Excel or Python, you can get a wrong answer. So fungus concentration is which one is the independent variable? This one is what?
Fungus concentration is independent. X.
Yes, this is independent variable. This is dependent variable. This is the short form. So later, if I just use this IV and DV, I hope that you can understand. So IV stand for independent variable. This is the dependent variable. Okay, that's why in the justification, we can say that, let's say, if this has a strong linear relationship, we can say that lipid productivity actually strongly dependent on fungus concentration, something like that, because this is the dependent variable. This is independent variable. Okay, whatever you change on the fungus concentration, lipid productivity also change. So if you want to do the manual calculation, you need to find the, okay. So here, independent variable, normally we represent it as X. This one, Y. Since this is simple linear regression, so we just we only have one independent variable. So to do manual calculation, you need to calculate summation of X, summation of Y, summation of X squared, summation of Y squared, summation of XY. How to calculate this expression? This is your X. Where is mine? Okay, so this is your X. You can find your summation of X here. This is your Y. You can find your summation of Y. Then how to calculate your summation of X squared? You need to square each of this value. Then you can get summation of squared here. And then you need to square this value. Then you get summation of Y squared. How to calculate XY summation? Multiple these two value. Then we get XY, XY, up until XY here, then you can sum up everything. You can get the summation of XY. So the formula, so what is the number of observation? N is equal to 10. Normally we use N to represent number of sample ataupun or observation. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n equal to 10 here. So you can find the formula of Sxy and also Sxx because beta 1 is actually Sxy over Sxx. So this one you can find it in your lecture note. What is the formula? The formula is actually in terms of this. Okay, so you can get the slope. You can also get the intercept by using this formula, y mean minus beta 1 times x mean. Okay, beta 1 here is actually you already got here. For y mean here and x mean, sibuk je. For the y mean and also x mean, you can calculate by, sum up all the x over n. This one y, sorry. So all the y n. For this one, sum up all the x over n. Okay. So this is actually like b null equal to summation of y over n minus beta 1 that you have calculated times with summation of x over n. Yeah, then you can get the answer. Since you have tried this, then I have the answer from you guys. What is the y? Someone please.
You mean summation of one?
No, I mean what is the regression equation?
Oh, I got 24.08 plus 5.6155x.
Okay, good. I also got this answer. Okay, for the estimation part, as you can see from the data, you are given from 0.5 up to 10.5, but there is no 5.5 information here. So they ask you to estimate what happened to the lipid productivity when the fungus concentration is 5.5%. So when x is equal to 5.5, y is equal to what? You can just substitute 5.5 here. So what is the answer? Someone, please.
54.96.
54.96.
Yep.
Okay, gram per day because it has a unit. So for me, this is personally for me, I prefer for you to consider 4 decimal places like this, maybe 24.0895. For this one, 5.6155. So the final answer I got here 54.69748. But it's okay lah if you get 96 is also can. Okay, is it clear? Any question for exercise 2? Guys. Ada soalan tak?
Saya tak ada.
Okay, good. Next, I will proceed with the exercise 3. Okay, for the exercise 3, this is the format extended assignment. You are given with a lot of data. Normally, we will not provide you the data set. We will give you a link for you to extract all the data from the link. Okay, like this question, you are given this link. Okay, if you are using Excel, then you can copy. If you're using Python, then you can call by using command as taught by Mr. Nahim. So, okay, as you can see from the link, there are a lot of data and also a lot of variables. And then, okay, here the first question, estimate the linear regression equation between the yearly amount spent and each of the variables. We have 1, 2, 3, and 4. Okay, I want you to tell me which one is the DV, dependent variable.
The yearly amount spent.
Okay, so good. Thank you. So this is the dependent variable. So this is the independent variable. Okay, remember, this kind of data sets actually are more suitable for multiple linear regression. But for this exercise, since they give you the same link, the same data set, and then they want you to apply simple linear regression, then you just have to do so. That's why you are given with the hint, there are 4 simple linear regression equations, because they want you to test each pair between this dependent variable and first IV, the second IV, and the third IV, and the fourth IV. So you will have 4 pairs. Okay, that's why you are given this hint, 4 simple linear regression equations. Okay, but supposedly based on the nature of this situation, these data sets is more suitable for multiple linear regression, but it's okay, just follow the question. So you need to develop 4 linear regression equations. So if you're using Python, so it's okay, but mine, I'm not good in Python, so I use Excel. So this is the software output that I get. Okay, do you know how to do this Excel to get the software output from Excel? Do you guys know the steps? Anybody has problem with finding the software output using Excel?
Sir,
Yes.
I think I have a problem regarding the downloading the data.
Oh,
But last night I tried to open the link, but I
okay.
couldn't find the download button.
Oh, that's why I said I'm not expert in Python, but I'm using Excel. For Excel, you need to copy all the data one by one. I mean, like, you just click the link, and then you will see all the data, right? And then you just highlight everything and then copy on the Excel sheet. I was doing that. I'm doing that. I'm not sure how to download it. Systematically, yes, I'm doing manually because I'm not good in coding and what so on. Sorry. So
Alright,
I
alright.
just yes, I suggest for you, if you're not don't know how to download it, you can just copy everything, all the data, and just paste it manually lah. Okay.
Alright.
Okay, good. But anybody has problem with finding the software output using Excel? Because I think Dr. Hanita already gave you the manual for the Excel, right? So anybody has problem? No, right? So
Sir,
yes.
actually, can you just show us like one time how to do it on Excel?
Okay, wait sekejap, sabar set no. Sebab sekejap, macam mana nak ni? Okay, tekan ni. Sekejap, saya stop sharing, then I need to open my Excel lah. Sekejap Okay, can you see my Excel?
Yes, sir.
Yes.
Okay, good. So this is all the data that I have copied from the link. So we have 1, 2, 3, 4 independent variables, 1 dependent variables here. We have many data. So I divided into 4 sheets here, sheet 3, 4, 5, 6, because we have 4 pairs of data. So the first one between average station length and also yearly amount spent. So the first thing you need to do is make sure you have, you need to click data. Is it data? I also forgot. Oh, I see. For the I'm using different laptop actually. Okay. For data, you need to have, okay, when you click data, you need to have one more here, data analysis. Let me wait. How to do it? I also forgot. Let's say option. and then add in. If you don't have the data analysis tool, then you need to install it. Is it this one? So is there any changes? Because I'm using different laptop, so that's why there is no data analysis tools. Wait, I will try to. I go. Sabar, saya add in. Go. Okay, sorry. So analysis toolbar. This is try and error. So okay. I hope. Yes. So that is how you get your data analysis tools. Can you see here the data analysis tools? If in your Excel you don't have the data analysis tools here, you can just go file and then options. You can go add in. You just click analysis toolbar because just now this one is actually in the inactive application. You just click and then you can go, click go, and then click here, and then okay, then pop up here, data analysis. Then the first step, you just click data analysis here, and then choose regression, then okay. So for the input Y, that's why I said it's very important for you to identify which one is the dependent and variable correctly, independent and independent correctly. So for the Y range, this is your Y. So you just highlight from the here the value up until okay. You just highlight lah, just macam ni. I'm not sure how to do it more scientifically. Sekejap. Okay, so for the input, the independent variable lah. So you can click. I prefer you to click output range because you can set which column, which row you want to come out the result, the software output. Wait, let me just click N2. Okay, N2. Then okay. So this is the result. Are you clear?
Yes, sir.
Okay, good. So you can just copy and as usual lah. Macam tak biasa je copy ni. Sekejap Stop sharing. Okay, so next. Okay, let me read the question first. Second, they ask you to find the standard error and discuss the standard error of estimate and then the coefficient of determination. Next, based on the ANOVA, test the significance of your every regression model using the p-value. Next, analyze whether each of the independent variable is statistically significant to the yearly amount spent using t-test. Last question, they ask you to estimate. This is the given values. Okay, so since we have 4 pairs of data, so the first one is between the yearly amount spent versus average session length. Okay, so this is your R square. This is your standard error of estimate. This is your ANOVA table. This is your ANOVA table. That's why I said ANOVA table only involves F test. This is F statistic. Why I call it as F statistic? Because in order to find the F statistic, you need to do test statistic, right? So that's why I call it F statistic. So this is actually the p-value for the F. This is p-value for the F test. Okay. So the bottom table is the regression table. Don't be confused. The middle one is the ANOVA table. The bottom one is the regression table. So this is the intercept, which is the B0. This is the X variable. You can name it as average session length. Okay, so this is your beta 1, the slope for beta 1. This is the t-stat. That's why I said, again, ANOVA involves F-test only. In ANOVA, there is no t-test. Okay, t-stat, same like this. This is F-stat, this is t-stat. You get it from t-test. This is the p-value for the t-test. This is the F value for the F-test. And this is the p-value for the F-test. So this is the p-value for the intercept. This one. This is the p-value for the slope. So in order for you to find the significance of the slope, you just need to look at this. This one we just ignore because we don't want to see anything from the intercept based on your syllabus lah. Okay, don't be confused Normally student akan tengok yang this one. Ataupun dia macam just randomly pick whatever number here in the table. So don't be confused. Make sure you be aware lah. So how to get the first linear regression equation? You can refer this coefficient. Since this is your B slope, this is your B1, then your linear regression is equal to -434. Don't forget your negative. Last semester, there are a lot of students. Just ignore the negative. So 434.001 ataupun when you consider 4 decimal places, 0020 plus 28.2339 X. Okay, I prefer for you to define the X and Y. What is your X? What is your Y? Even though Dr. Hanita didn't mention this, but I prefer for you because for simple linear regression is okay, but for multiple linear regression, there are a lot of independent variables. So better for you to define it first. So X is average session length. Y is the yearly amount spent. Okay. Then you can this is your linear regression equation, the simple. You can model it. So next question, they ask you to find, I will just show you the first pair, and then the second, the third and fourth, I will call your name randomly to share your screen. Is it okay? If we have time. Okay, we have time. Yes?
Tanya, regarding the t-test though,
okay.
Actually, how we can evaluate the data regarding the t-test?
Okay, that one can how to evaluate the data from the t-test. Okay, that one is for this question, number 5. I will explain later. I will do it one by one. Is it okay?
Okay.
Okay, thank you. So the first one settle, which is the linear for the linear regression equation. The second one is the standard error. Standard error is this one, 74.2641. So when you refer your lecture note for the standard error, you can justify by using SSE. Okay, you can see your lecture note right now or later, but then there is a statement mentioning that you can, just justify your standard error by using SSE. Okay, can you tell me where is the SSE? SSE. Where is the SSE? Sum of square of error, is it? Where is the SSE?
It's in the ANOVA table under SS. Row is the residual.
Okay, good. So this is regression. This is the residual, or we can call it as error. Sebab ni R, so ni R. So normally we use SSR for regression. So we don't want to use the same SSR for the residual. So that's why we use SSE. So this is the SS, this is the E. So this is the SSE. So you can justify your standard error by using this value. They say if the SSE higher, so meaning that your regression model It's not really successful. You can just refer your lecture note. Why? Okay. SSE is actually related to the standard error. Okay. In order to find the MSE, you need to divide the SSE by this one, right? DF for error, as I said in the first exercise. The MSE is equal to SSE divided by degree freedom for error. This one is degree freedom for error, 497. So MSE is this one. Remember the question that I asked you to highlight? The standard error is actually square root of MSE. Standard error is actually square root of MSE. You try square root MSE. Do you get the same standard error? Try. Using your calculator, you try square root the MSE. Do you get the standard error value? Dapat tak?
Yes, sir.
Yes, good. So remember, standard error is the square root of MSE. That's why you can justify the standard error by using SSE. We don't consider the DF lah. So as you can see, the SSE is very big. 2 million, is it? 2,741,035.317. So it's very high. So based on the standard error, based on the SSE, the regression model is not really successful lah. And then next question, they ask you to discuss about the R square. So as you can see, the R square is just 12.46%. So this one also is very low percentage. So we can say the regression model is also not really successful by referring the R square value lah. Something like that. That is for the third question. You can just use the same statement, the same words in the lecture note. Okay. So the next question, the next question is what? Okay, based on ANOVA, test the significance of every regression model. Okay, I want to highlight. Just now I already mentioned that ANOVA involves F-test. Okay, hypothesis testing, you can use F-test to do hypothesis testing. You can do t-test to use to do hypothesis testing, but hypothesis testing by using f-test is only for ANOVA. Okay, remember ANOVA. Remember. I want you to take note for this part. ANOVA only to test. Normally we use ANOVA to test the significance of your regression model. Okay, ANOVA normally we use to test the significance of your regression model, but t-test, doing hypothesis testing by using t-test, normally we use to determine whether the independent variable is statistically significant or not. They are actually two different things. This one to test the significance of your regression model, meaning that you can see whether your equation, your y equal to beta naught plus beta 1 x is well fitted or not. Okay, for this one, you can identify whether your x is significant in expanding y or not. Okay, you can see the application in simple linear regression, but usually you can see in multiple linear regression, because in multiple linear regression we have many independent variables. So from there you can identify which independent variable that are actually more significant in expanding y. Okay, but for simple linear regression, you cannot see exactly the application here, but this is actually the concept. Okay, that's why in the question, based on the ANOVA table obtained in the software output, test the significance of your regression model here. But for the t-test, analyze whether each of independent variable is statistically significant to yearly amount spent or not by testing the significance of the slope. Okay, you see there are two different things. Okay, if they ask you to test the significance of the regression model, then use f-test. If you, they want to see which independent variable is more significant in expanding the y or in in towards the y, so you can use t-test. Okay, is it clear for now? Okay tak sekarang? Faham tak? For now, is it okay? Are you clear? Okay, good.
Yes.
Okay, good. So, okay, in order for you to do hypothesis testing, as you have learned before, hypothesis testing, you will involve this one. You will have B1 equal to, since this is simple, H1, B1 not equal to 0. So the second one, you need to find your F test. Let's say this is for ANOVA. So F test, you can get the F stat from the table. And then you need to find the F critical by referring in the F table. Okay, so what is the F stat here? Based on this result, this is your F stat, 70.7538. 70.7538. This is your F stat. So if, okay, by finding the F critical, as you have learned in your statistic course, this is we call traditional method. Do you remember? Ingat tak? This is traditional method. And one more, you can use p-value method. Do you remember? During your last year punya course, statistic course. Ingat tak?
Ingat sikit.
Janganlah ingat sikit. Kena banyak makan kismis tu. Okay, so if the question didn't specifically mention anything about these two methods, you can use p-value or traditional method. But remember, if you want to use traditional method, you need to find the F critical by finding it in the F table. But you can also directly use the p-value since you already have the p-value. You can just use p-value because alpha is given 0.05 here. I think for the data analytics, since you are referring the software output, I think for you it's much easier to use the p-value method because you already have p-value here, 4.323 power of negative 16. 4.323, is it 323? 3213. 3213 times 10 to the power of negative 16. So I think I more prefer for you to do the p-value method. But if you want to use the traditional method, you need to find the F critical. Okay, so then you can, this one to either one. So next, after this hypothesis, the test statistics, next decision. After decision, you need to justify your conclusion. This is the hypothesis testing. This is what we call hypothesis testing. Okay. So for ANOVA, we use F-stat. Okay. So for, if I want to use the p-value method, so the decision here, since our p-value, the p-value is lesser, smaller than the alpha, therefore we reject H null. As you can see here, this is a power of negative 16, it's very small value compared to the alpha 0.05. So lesser than alpha. So therefore we reject H null. We reject H null. This one actually no relationship. No linear relationship. This one has linear relationship. Okay, if we reject this one, meaning that this is our conclusion lah. So we can say that since this is ANOVA, as I said just now, ANOVA, we want to test the significance of the regression model. So we can say that the regression model at the, you can say like, wait, you can say there is a linear relationship between the IV and DV. You can say the regression model is well fitted. You can say like this. Yes, remember for F test, you cannot identify whether the X is statistically significant or not. You just can say that the model is well fitted or not well fitted. That's all. You can say just regression model is okay or not okay. Just that's all. Normally you can see this application in multiple linear regression. When you have more than one independent variables, you just can say when you consider y equal to beta naught plus beta 1 x1, beta 2 x2, beta 3 x3, and so on, you can just say the model is well fitted. But you cannot identify which variable is more significant in describing the y. So from there, you need to use t-test, doing hypothesis testing using t-test. So this is the next question. So, yes?
Nak tanya yang pasal ANOVA table kan. Just now saya cakap that for ANOVA we need to use F test, right? But how suddenly kita guna p value pula?
Oh, okay. You confuse ni. Ni mesti masa last semester statistik ni tak ni. Okay, tak apa, it's okay. So dalam test statistik, in test statistics, in your syllabus, you have F test and you have T test. Okay. To justify this test, you can use traditional method or p-value method. Same goes here, traditional method or p-value method. So the result will be the same if you use either one, also the same. So F test you use for the ANOVA, is it? Where you can identify whether the regression model is well fitted or not. So for the justification, for the F test, you can use traditional method or p-value. But for traditional method, you need to find F critical. But since you are referring your software output, which is, it's already give you the p-value, so I think it's more convenient for you to use the p-value method. No need to find the F critical like this. So are you clear? Sama je.
Yes.
You can use either method. You can use traditional method or p-value method. But since to make it easier, you already have p-value here. You already have p-value here, but you don't have F critical. You don't have T critical. I think it is much easier for you to just refer the p-value by using the p-value method. Is it okay?
Yes.
Good. Next, we want to identify whether the whether this independent variable, this average session length, is statistically significant to yearly amount or not. So we need to do hypothesis testing by using t-test. So as usual, hash naught b1 equal to 0, hash1 b1 not equal to 0. So I want to use p-value since I'm very lazy to find the t critical. So just look at the software output. You have p-value for the t-test. Remember, this is the p-value for your t-test, t-stat. Don't refer the p-value for your intercept because we want to see this one, b1, the slope. We don't want to see the intercept. This row is for intercept. Where is my cursor? Okay, this one. This is for the intercept. This is for the slope. You just refer this row, this slope, p-value. So your p-value is 4.3213 power of negative 16. 4.3213 power of negative 16. So when you want to use p-value method, this is the alpha 0.05. So what is your decision? Since the p-value lesser than alpha, therefore we reject H null. Alahai. Something like this. What is the conclusion when you reject H null? So we reject H null. So we can say that the average session length is statistically significant significant in explaining the yearly amount spent. So meaning that, let's say, for multiple linear regression, if you remove the, let's say, for multiple linear regression, when you consider all the 4 independent variables, if you remove the average session length, it will give big impact towards the yearly amount spent. Okay, clear for now? Is it clear? Are you clear?
Yes.
I think for the last question, it's very easy. You just substitute the X, right? So are you clear for now? We have about 5 more minutes. I think tak sempat pun untuk discuss the other 3 pairs. Can you do it by your own?
Yes.
Okay. Can you do it the other 3 pairs? There are 3 pairs. The yearly amount, between yearly amount and time on website, time on app dengan membership, something like that. Yes, I want you to email me Muhammad Naim @yahoo.com. Okay, I want you everyone just provide me the software output in the Excel, and also the hypothesis testing, the linear equation, the standard error, the R-squared, the hypothesis testing, ANOVA, hypothesis testing, t-test, this is for f-test, this is the t-test, and also the last equation, and last question. Are you okay? Boleh tak? Provide me in the PDF file.
So just do like what you did.
Yes, just do what you did, including all the justification. Okay, I just want to see, because this is the format of your extended assignment. If you are given this, let's say this is not included in your extended assignment, maybe in your assignment, maybe in your test, I'm not sure, but maybe in assignment. So this is the format. I want to see your justification. In previous semester, there are not tutorial slot in data analytics, but for this semester, Dr. Hanita wants you to at least understand the concept of statistical part lah, the statistical analysis. So I want to see your justification, your explanation, everything. Just do like what I did. The hypothesis testing, this one, and also for the linear equation, you need to define it first. And then for the R-squared, the standard error, you can justify by referring in your lecture note. Okay, is it okay? Submit to me. Can I give you? Can I say the deadline tonight? Is it okay for you? I think it's very easy, right? Since you already have tried, I just want to see your answer. Is it okay tonight before 12? Before 12 AM.
Sir, how about 1 week?
1 week dahsyat lah. You dah try dari last week kan? I dah try. I dah suruh. 1 week macam dahsyat. Okay lah. I give you by tomorrow before 12 AM. Okay. Sebab after this you need to try for multiple tau. Kalau 1 week, next week kita dah try for multiple. Boleh? Tomorrow before 12. Is it okay?
12 hari ni ke 12 Esok means sebelum hari Ahad.
Sebelum hari Ahad.
Okay.
Is it okay sebelum hari Ahad? Before 12 hari
Okay.
Ahad. I mean Sunday. Sunday 11:59 PM the last. Sunday pula. Saturday, sorry. Saturday 11:59 PM last. Boleh?
We try our best, sir.
Janganlah we try our best. Actually this one tak ada marks pun. Kalau you tak nak submit pun I tak kisah. That's why I said kalau student betul ada effort, I will help. Kalau tak ada effort, it's okay, up to you. I just want to see because macam last time, yesterday, saya buat untuk kelas group ME2. Is it ME2? Right now it's ME1, right? ME2, I pick randomly student to explain. Nanti diorang share lah, diorang punya Excel. So for your class tak sempat. So diorang share diorang punya Excel. Even though I dah explain macam ni, diorang still salah ambil value, diorang tak faham ni. So since this class kita tak sempat, I tak boleh nak pick randomly your name. So this is another initiative lah untuk saya tolong you. But then kalau you tak nak submit, it's up to you. Saya okay. Tak ada mark kah pun untuk ni. But then I just nak tolong you. Sebab nanti assignment maybe I yang mark ke apa ke. So I akan marah lah tengok student macam I ajar macam tak ni. Macam tu lah. Up to you lah. It's okay. So Saturday 11:59 is the deadline lah. So okay. So dah pukul 12. Boleh? Can we dismiss the class? Any question, Mr. Nahim? Are you okay? Any question guys?
Rasanya tak ada.
Tak ada So kalau you nak submit, saya okay sangat. Sebab that is your effort. But if you don't want, it's okay. Tak ada markah pun. Okay.
Sir, by the way, kan saya cakap tadi kena hantar kan? And if kalau ada salah ke apa, do we get the feedback?
Kalau you salah, you bagi nombor telefon, I contact you personally. I WhatsApp you which one yang you salah. Saya tolong sedaya upaya yang boleh.
Alright.
Boleh, you bagi nombor telefon. I akan contact you personally. I akan tegur which one yang I rasa macam tak okay. Boleh?
Alright.
Okay.
Baik, sir.
Okay. Thank you. That's all for today's class.
Okay, thank you sir.
Okay, thank you. Bye-bye. Assalamualaikum. Take care. Stay safe. Jaga diri. Assalamualaikum.
You too.
Apa? Okay, see you too. Okay.
You too.
Okay.